Hello maths fans, logarithms today, and this is to do with powers, exponents, exponential stuff. So you're probably used to seeing things like this: 2 to the power of 3 equals 8, and here the exponent is 3, or the power is 3. We can also write that in something called logarithms, and logarithm notation is basically a way of undoing a power, if that makes sense. The logarithm is to the power what the square root is to the squaring. Kinda? So, what we can do with this is we can say that log for base 2 of the number 8 equals 3. And that's telling us that if we have a base of 2, what do I power it by to get 8? That's what this kind of statement at the front there is. It's saying, what's the exponent of 2 that gives me 8? And the answer would be 3. The power of 3 gives me that. Let's look at some examples with this. But the basic idea is that we are finding powers. We're finding the exponents. So, if 2 cubed equals 8, could be rewritten as log base 2. That base 2 is crucial. That tells us the base number there equals 3. In general, and this only works when b is greater than 0, so it doesn't work. You can't find a negative logarithm. When we have a to the power of x equals b, so like here, we can write log base a of b is equal to x. So that's a way of rewriting these sentences. If you followed that, you've got the basics of this down. Let's look at some sort of questions that we might get. Let's try and understand what we're saying here. So log base 5 for 25. What's that asking? That's saying, what's the exponent of the base that gives me this answer? Well, the exponent of 5 that gives me 25, it's kind of saying what's x in this. What power of 5 gives me 25? And so in this case, I know that 5 squared gives me 25. And we can do this, we can use logs for any values. Here it's kind of obvious because I know that 5 squared is 25. But if that number was 93, I don't know what I do 5 to the power of to get 93. So we use logarithms. Okay, let's look at another couple of sort of straightforward examples. Log base 3 of 81, well, that's saying 3 to the power of something gives me 81. What is that power? What power of 3 gives me 81? Well, I happen to know that 3 times 3 times 3 times 3 is 81. 3 to the power of 4 gives me 81. So I can say log base 3 of 81 equals 4. Log base 10, this is the most common log. If you see on your calculator the log button, as a default, it's using base 10. So base 10 is a really useful one to look out for. Anyway, log base 10 for 1 million, what's that saying? It's saying if I've got a base of 10, 10 to the power of something, 10 to the power of something gives me 1 million. 10 to the power of, well, 10 times 10 times 10 times 10 times 10 times 10. 10 to the power of 6 gives me 1 million. And because it's such a common base, if you ever just see log 1 million, it's talking about base 10. You can assume it means a base of 10. So if you don't see a base written in the log, assume it means base 10. But there we go. It's saying what power of 10 gives me 1 million? 6. Now, there's a few things to look out for. There are certainly five things that can help us or trip us up if we sort of understand them fairly clearly. All of these come from fairly simple concepts, but because of the new notation, they might seem a bit intimidating. In general, a to the power of 1 equals a. Think about that as if I've got 3 to the power of 1, well, that is just 3. And so kind of working backwards from that, if you ever get log base a of a, the answer is going to be 1. So for example, log base 3 of 3, that means what power of 3 gives me a result of 3? 3 to the power of something gives me 3, well that's 3 to the power of 1. Does that make sense? Hopefully. On we go to the next one. Now, anything to the power of 0 equals 1. Hopefully you're aware of that. 5 million to the power of 0 is 1. 8 to the power of 0 is 1. Anything to the power of 0 is 1. And therefore, whenever you have log base anything of 1, we get 0. So it doesn't matter what the base is. If we're finding the logarithm for 1, it's going to be 0. Because anything to the power of 0 equals 1. So if you ever see, for example, log base 2 of 1, the answer is going to be 0. And then we come on to these last two, which are kind of together, and this goes back to that very first screen. If I just scroll back to that, you'll remember, sorry, there's a few scrolls there. You remember it said b has to be greater than 0. Well, that means that any time that you're trying to find the logarithm of 0 or a negative, I shouldn't have really scrolled back, wasn't that important. Anytime you're trying to find the logarithm of a negative value, it's undefined. It doesn't work. There's no power of 10 that gives me a negative number. If I do 10 to the power of minus a million, it becomes a very small number, but it never becomes 0, and it never becomes less than 0. So anytime that you're trying to find logarithm for 0, it's undefined. Anytime you're trying to find it for negative, it's undefined. I'll just show you that graphically. Here is the graph of y equals 10 to the power of x. So here are the values of x, the powers, going up 0.5, 1, and obviously 10 to the power of 1 is 10 there. 10 to the power of 2 would be 100. Coming down as we get into the negative powers, 10 to the power negative 1 is 1 over 10. 10 to the power negative 2 is 1 over 10 squared. It gets very small, but it never goes below 0. Okay? We'll come into that in more detail at a later date, but important to notice no negative values for that. Here's the last little rule to look out for, and this is quite a crucial one. This is really starting to understand that relationship between the power and the log base. I think it's probably easiest if we look at an example and then come back to that. So, if I've got a base of 10, log base of 10 for 10 cubed, that's saying what power of 10 gives me 10 to the power of 3? Well, 3, isn't it? 10 to the power of 3 gives me 10 to the power of 3. So this log base 10 for 10 kind of cancels out, and the answer is 3. So if you ever see the same base in here, and then the base of a power that you're trying to find the logarithm of, you can kind of scrub it all out and it's just n. So in that particular example, log base 10 for 10 to the power of 3 is 3. If we had log base 2 for 2 to the power of 9, it would be 9. We can, I mean, this isn't good maths teaching, but you can kind of scrub all that out and just take the power there. Because we're saying, what power 2 gives me 2 to the power of 9? Well, 9. Hopefully that makes some sense. Make a note of those 5 rules there. So the rules on there, make a note of those for sure. I'd pause the video if at all points as you're going through, take these examples. Also make a note of that rule, and then have a go at this. So here's 3 for you to try. Give it a go, pause the video, and I'll give you some answers now. Hopefully you've paused. Right, first one there. As I say, log base 2, 2 to the power of 6, well that's saying what power of 2 gives me 2 to the power of 6, so it's 6. Any log base for the number 1, the only way we get one is having a power of 0, so that is 0. And the last one Log base 5, that's saying 5 to the power of something equals 5. It's 1. All right? Hopefully you've made some sense of that. Just going to give you a little bit of a bonus information. I'm just going to show you how to enter these onto a calculator. Now, for the majority of log stuff you're going to do, you're just going to do this log here. And that is a base of 10. Now, if you do want a different base, what we need to do is we need to go math here. So when you go into your menu, we're just in the run matrix, and then we want F4 for math, and then it's got this log AB F2. So if I put that in, I can now enter my base. So if I want a base of 2, and I want to put in, let's do the 2 to the power of 6 there, why not? Check that I got the right answer, and we get 6. You can see that. If I want to do log base 10, I can just go straight to this log button, log base 10 for 1, and you see we get 0, and log base 5, I would need again to use this log AB. So that's just a little thing useful to be aware of, but we do need to understand these relationships. Okay, you can't just go straight to the calculator always. Anyway, hopefully that makes some sense.